If in your mind, if evals is just a metric, then you're thinking about evals wrong. It's not a metric. It's an entire process.
That was Hamel Hussain, machine learning and AI engineer extraordinaire, talking about why evaluation isn't just a metric, it's the whole process. I recently asked Hamel, how do you make AI products better?
How do you make it better? What is better? Can you describe what is better? The struggle is, can you articulate what is better? The process of you articulating what is better is the main focus of AI engineering. It's pretty clear that humans aren't great, especially for non-trivial products, at describing exactly what they want without seeing LLM output and responding to it. And that helps externalize what you want. In the process of going through evals is just, there's evals, but there's looking at data. And you have to give the LLM your requirements somehow. And knowing what you want is hard. Discovering what you want takes work. Discovering what your users want, that takes work. So evals and that is wrapped up so tightly together.
We also talked about how error analysis helps you figure out where to focus first.
There's an infinite surface area for you to test and for you to eval. And so you need to let the error analysis help you prioritize. So for example, if it's even things like RAG, I would say, let the error analysis show you that RAG is a problem, and then specifically retrieval is a problem, before you go in depth with trying to set up eval harnesses for your retrieval. You might get to it anyways, but you need to prioritize and focus. And so again, the error analysis helps you do that, and you can respond to the error analysis.
Those were clips from a guest talk Hamel gave in my recent course, Building LLM Applications for Data Scientists and Software Engineers. We've decided to make this conversation public because we think a lot of people can get value from it. If you're interested, our next cohort kicks off July 8, and it's time for the Americas and Europe and Africa for the first time. You can find the link to sign up in the show notes. Hamel and Shreya Shankar also have their evals course coming up, which we've linked to as well. I just took their course myself, and it has fundamentally changed how I build, ship, and teach AI products. If you're looking to learn how to build production-grade AI and LLM applications, covering design, debugging, evaluation, agents, and more, check out my course, which I co-teach with Stefan Krautchik, who's now working on agent infrastructure at Salesforce. If you want a deeper dive into evals specifically, Hamel and Shreya's course is state-of-the-art. Links to both are in the show notes. We've also put the video of this conversation on YouTube. That link's in the notes as well. And if you enjoy the podcast, please consider leaving us a review on iTunes. It really helps. I'm Hugo Bown-Anderson, and welcome to Vanishing Gradients. Hamel, correct me if I'm wrong. Hamel, you started off a lot of your career like doing consulting and helping people with like business problems, and realized in trips to Las Vegas how important actually understanding business problems can, like people like data this, data that, data what, and you're like, hey, what are you doing? What are you trying to solve? So Hamel has been like incredible force for me to just reset what problems I'm actually trying to solve. And then we first met a decade ago when you were working at DataRobot, working on some real cool automated machine learning tools that allowed people to really, a lot of the drudgery of data science and data cleaning and data munging and that type of stuff, solve some of that, but also really solve. DataRobot automates a lot of the hyperparameter tuning and model selection. There's a big button, right, where you can press and it does a lot of the stuff that we all did in spreadsheets back in the day. And so I met Hamel in beautiful city of Boston about a decade ago. Then Hamel went to Airbnb and moved to the West Coast. Speaking of spreadsheets, I think you've said this publicly, Hamel was excited to get in the weeds with big tech, hardcore, global scale machine learning. And he said to someone, hey, can you send me like the details of this model? And they sent him a non-version spreadsheet via email or something like that. And so I think that was a shock to the system, that knowing, even at places like Airbnb, these types of things happened. After that, Hamel was at GitHub, where he worked on, among many other things, essentially one of the first coding assistants, dude. Did I get that right?
it was actually, no, I worked on semantic code search. It was
Yep.
like but then it was like some research that kind of precursor to the Copilot work.
Awesome. And after that, we worked briefly together at Out of Bounds, but then Hamel, like myself, Hamel was part of the inspiration for going freelance. I was really had a lot of concerns about going freelance, but seeing what Hamel did and really encouraged me to, for lack of a better term. And sorry, I just remembered one thing you said to me, which isn't safe for work. But since then, Hamel has been helping people build LLM powered, AI powered software and really thinking through first principles and helping people adopt the tools necessary, that type of stuff, but stepping back and thinking through what are we doing and why. And I think the reason I wanted to frame it like this is that's one of the things I love about your recent post, Hamel, which we're here to talk about, which is a field guide to rapidly improving AI products. And I wonder if to open, could you just tell us why you wrote this post?
Yeah, the field guide.
Yeah.
Yeah, so I think like a lot of people get caught up in, I don't know, like agent frameworks, prompting strategies, RAG databases, all kinds of stuff. And they focus all of their attention on that. But it turns out a lot of fundamentals are always missed. And those fundamentals, I think, are more important than those. Because the tools, it's good to know what the tools are. Essentially, what people miss a lot is like, hey, how do you look at data? How do you think about evals? You can get stuck really fast. I think Hugo's been teaching that in this course. I even saw when I joined the call, he was talking about that. It's probably no surprise, but you would be surprised. No, or most people don't go about things that way. They go about, hey, let me just put the tools together, and that's it. And it takes a fair amount of skill actually to analyze data. There's a lot of data science, like just from a not. There's a lot of value in being able to look at LLM logs and telemetry and analyze that data and dig through it and have a good nose for where to poke. And that you can do that happens with practice. But I think that's a really key skill. So that's
Absolutely.
why I wrote the guide, really, is to think about those things and think about some other things. Basically, I highlight a lot of the stuff that I think is very important that people tend not to focus on.
I appreciate that context. And I'll link to this and put it in our course wiki. But Hamel also had Hamel was doing office hours. I was about to tell you what you were doing, and there's no need for that. Hamel was doing a series of office hours where he just invited people to come and chat about what they were building on the condition that Hamel could share them publicly, essentially. And every conversation went exactly the same way. It was modulo detail. It was like, I'm building this agentic thing. I'm doing this multi-turn, yada, yada, yada. What do I do next? And Hamel said, have you been looking at your traces? Have you been doing this and that? And most people just weren't doing those things. And that's actually why you stopped doing the office hours, if I recall correctly, because it was just the same.
Yeah. No one was doing error analysis. No one was looking at traces. Everyone was pretty, like, universally, they were lost. What do I do? What do I do next? I have my prototype. How do I make it better?
One thing I'm interested in that we haven't talked much about in the course, and we can get to different points. You've got some wonderful high-level summary, how error analysis consistently reveals the highest ROI improvements, which we have talked about, why a simple data viewer is your most important AI investment. And I actually showed people how I was, a la stuff Greg was doing, just spinning up, vibe coding custom JSON viewers where I could do pass, fail, reason, etc., logging, boom, and also in spreadsheets. But you have a wonderful section on how to empower domain experts, not just engineers, to improve AI. And I just love if you could give us kind of like the greatest hits of that. How do we do that in an organization?
Yeah. So, okay. So one key failure mode that I always see is the prompt engineering is the tools that people build and the infrastructure people build are done in such a way that only engineers can change prompts. And in most cases, that's a really bad idea because your engineers are not the domain experts. Unlike GitHub Copilot or developer tools, you're working on developer tools, okay, fine, doesn't matter. But if you're working on things that are not developer tools, then hiding the prompts from the domain expert is going to slow you down tremendously. And it's a really bad idea. And so one of the ways I talk about in the post that's really popular is this idea of integrated prompt environments where it's like, you can think of your UI in your app, but you just have an admin view that allows you to change the prompt. perhaps with templating, perhaps with other settings, whatever. But that's really important so that your people on your team can change the prompt. So yeah, that field guide is full of stuff like this. Like when you read it, I think what I've heard and the way I felt when I was writing it actually is like it's all common sense, but it doesn't, maybe it's not apparent if you haven't done this before. And so it just hopefully saves people time by doing things this way.
Totally. And you'll recall that in the first, when we taught this course in January, you and I did a live stream about a lot of these things. And there was actually one wonderful participant in the court, Alona from Hamburg, who she tuned in at 2 a.m. local time every time. And she was like, wait, what? She was like, but I do this. That's what we do. And she couldn't grok that people didn't do this because she comes from a very like data analyst, data centric background. So to her, of course, this, but now seeing we have so many people coming into the space, and LinkedIn, or as you all know, I like to call TikTok for adults, shows us like model and tool focused stuff all the time, which is fun and shiny, but getting back to basics is incredibly important. There are some great questions in the chat. Natalia actually had a great question for me, which is when doing evaluation driven development, how do we iterate? What are we changing in the iteration process? So let's say, so I've framed it like this, Hamel, that when you build out an MVP, you also want an MVE, a minimum viable evaluation framework, like just a little harness that when you switch out the model, you can get results and you iterate on that as well. But when you iterate on your AI system, how do you start thinking about iteration? What knobs are you turning? And you're versioning everything as well, to be very clear.
Yeah. Okay. So to be clear, okay, first, it's okay to start with vibe checks just for a little bit. You got to build something, the MVE, or what do you call it? MVE? I forgot what you
Yeah,
call it.
MVE.
What's
Yeah.
the difference between MVE and MVP? What's the
So
E?
the P is the
Or,
product and the E is the evaluation.
oh, E is okay. E is valuation. Okay. So yeah, if you have a minimal product, you should totally vibe code your way to minimal product. Like you need something. You need to understand what you want. And then like, you can, when you first start doing error analysis, like this is after you have some minimal product and you have an idea it works. You don't necessarily want to be dogmatic about evaluations either. Like when you first do error analysis, you'll see a lot of stuff that's obviously broken. Okay, like my RAG is not, has like syntax errors and it's not, or not other errors that are not like pulling documents half the time, or I'm I have these other like errors as engineering problems of some kind. Should you write evals for that? No, just go fix it. So in the beginning, just fix stuff. Okay. You don't want to write evals for things that you know exactly how to fix and you're pretty confident that you can just fix, like right off the bat. You want to write evals for things that maybe it's something that you're not quite sure yet how to definitively get rid of and you need to iterate on. Then you might want to think about an eval for that. And there's some tension. There's some intuition. Like, it's not exactly, I would say it's not exactly like code tests. Hey, write tests. If you see an error, just write a test. LM evaluations tend to have some overhead. You have to think about the cost benefit of doing that. Even a unit test, even if it has cost benefit analysis that you should do, but like more so with I would say. And so you just have to be a little bit thoughtful and like when to write evals and when that eval is going to have a payoff. But if you are looking at your data, you're doing data analysis, I think you will find things that you should eval. So the example is, hey, if you're finding that dates are being interpreted incorrectly all the time, you're trying to make appointments, users are trying to make appointments and dates are being interpreted incorrectly. That's what I talk about in the field guide. That's a good example of an eval because unless it's some stupid thing that you know how to fix. If it's more, hey, that's a prompt engineering problem or a rank problem, that's a good something to make an eval for. You should also try, yeah, and you should make sure your eval is not super trivial and easy. Try to choose hard evals or evals that you don't quite know the answer to yet. That's my rough heuristic. You can write evals, but you don't want to paralyze yourself with them because you can do that. And I've seen people go in the opposite direction, like too much too. Let me write evals. Let me write evals prospectively about every single conceivable problem I can brainstorm in my mind. You don't want to do that. I would say you want to respond to the error analysis and let that guide you. Because, yeah, there's an infinite surface area for you to test and for you to eval. And so you need to, yeah, let the error analysis help you prioritize. So, for example, if it's even things like RAG, I would say let the error analysis show you that RAG is a problem, and then specifically retrieval is a problem before you go in depth with trying to set up eval harnesses for your retrieval. You might get to it anyways. You need to prioritize and focus. And so, again, the error analysis helps you do that, and you can respond to the error analysis. I don't know if that's clear. I'm just trying to give some intuition.
Super clear. And for me, and it is, you really are speaking, I see a lot of people nodding, you're speaking to the iterative nature of it. And I'd be interested in your thoughts on, so I built a basic retrieval app on workshop transcripts that I've shared with the class here. And I get them to label pass or fail, give a reason and that type of stuff. And in the first iteration, I'm not even getting them to give pass or fail based on groundedness actually, whether it's, so the question isn't even, is it a retrieval problem or not? That might come out in the wash. But so my question is, when first even evaluating stuff, you don't necessarily want to think across all dimensions, right?
So when evaluating stuff, I focus on what is the most upstream failure I see. So basically, if you imagine a chain of events or even a multi-turn conversation or whatever, whenever I notice the first failure, I just stop and I take note of that failure. That's like heuristic that helps you simplify things, right? And basically, you fix the upstream failures before you fix the downstream failures. That's what kind of that results in. So that's a simplifying way to go about things that tends to work. And yeah, and then when you're first doing error analysis, I would just focus on, I wouldn't even try to categorize it off the bat. I would just say, yeah, just observe and learn about what's going on, build some intuition, and then maybe start categorizing later.
Love it. It's diagnostic, right? And not prescriptive at this point. We've got a lot of great questions in here. Could people give a plus or a thumb to questions that they would like answered as well? Because we may not have time for all of them. So have a quick look in Discord. There is a good question from David about, you mentioned the costs of additional evals. And he says, we're not just talking monetary costs. I actually think we're not monetary but there are complexity costs in terms of having more evals. But what do you think about the space of costs for increased evaluation?
Yeah, I mean, there's definitely, depending on the kind of eval, there's compute API costs. But the most important one is your attention. You have a limited attention bandwidth and about what you are going to pay attention to. And you need to be very careful not to completely overwhelm that and have it be high signal as possible, which means like constantly thinking about your evals, curating them, removing some things that shouldn't be there. There's advice that goes around all the time. It's like, I saw one that I wrote about one recently, a YC company called Case Text. They went on this podcast and said, hey, you should try to get to 100% pass rate on your evals. And that is bad, because if you get 100% pass rate, means your eval is not telling you anything. So you should not saturate your evals. You should have them be sufficiently difficult enough so that, hey, like they're telling you something. They're just passing all the time. Might as well not have them. I don't know if that answered the question, but
definitely does. We have a question from Namit, which a lot of people would love more insight into. If possible, could you share any examples of quote unquote difficult evals?
Difficult evals. Okay, let me see. I think about this. Yeah, more difficult evals would be like, it's not about difficulty in the sense like, it's difficulty like more than you're not sure how to fix it. Okay, so off the bat, it's not like some obvious engineering error that you're like, oh, I definitely know why that's happening and it's so stupid, I should fix it. And a lot of these are like, tend to be more like LLM as a judge based, but they don't have to be. So let me just give you some examples. Hey, the user wants to go to the next step, but then the LLM is parroting back to the user unnecessarily. Would you like to go to the next step? Or things from the system prompt are being repeated into the output that aren't supposed to, like user IDs, things like that. And you're like, why is I wish the model wasn't putting that into the answer, and it shouldn't be. The latter one, you could test with code. You don't need an LLM as a judge. So it's not necessarily about the LLM as a judge or as a code base, but it's like, hey, the model's doing something. It's not really a syntax or engineering error. And I'm not 100% sure how I would just get rid of it right off the bat. I need to do some experiments. Then that's a good sign that it might be an eval, that you might want to have an eval so you can iterate on it.
Awesome. Natalia has an interesting question. She says evaluation is easy, and I just don't agree with that. But she asked, how do you make the LLM better? I'll generalize the question slightly and say, how do you make your AI system better? What type of, and we've talked about this briefly, and I do think you've said, let the error analysis guide you, essentially. But do you have any more? Firstly, do you think evals are easy?
No, it's not about, okay, it's really funny that there's a great comment. How do you make it better? What is better? Can you describe what is better? The struggle is, can you articulate what is better? The process of you articulating what is better is the main focus of AI engineering. And it's pretty clear that humans aren't great, especially like for non-trivial products, at describing exactly what they want without seeing LLM output and responding to it. And that helps externalize what you want. And the process of going through evals is just kind of a way that we describe it, but really it's like there's evals, but there's looking at data. And you have to give the LLM your requirements somehow. And, that, like, knowing what you want is hard. Discovering what you want takes work. Discovering what your users want, that takes work. So evals and that is wrapped up so tightly together. I just don't have a better word than evals. It's not exactly eval-driven development. It's just development. I just don't have the terminology. Maybe someone will coin something, or I'll maybe coin something one day. I'm not in the business of coining terminology, but so to drive home, it's the process of looking at data and refining your vision of what the AI should do and making it happen. That's the hard part. And you can't really make the LLM better if you don't have a precise definition of what that is. And evaluation is okay. So that's the top level. Now, if you go a little bit beneath that into more tactical things, you do need metrics that you trust to iterate and make it better. Otherwise, you're just guessing. And the more complex your system becomes, you might change a prompt to fix one thing, but you'll break something else. And without evals, you won't know. And so it's that constant process of, you need metrics, but the metrics have to be aligned very closely with what you want, with what your users want. And it's impossible to do that without going through this process. Does that help?
That helps a lot. And I do
Does anyone not convinced of that? I want to hear if someone doesn't feel like that is true.
Oh, great.
Because I will want to show you something. I can show you something that can help you.
Show us, please. I do want to say to this blog post, but this is in another answer to part of Natalia's question is we have this loop, and this is something we actually did a podcast on that this blog post came out of, but the types of what can you tune? You can change your system in some ways with prompt engineering, fine tuning with curated data, like changing other aspects of your retrieval. It's what levers you have in your system, and start with prompt engineering, few shot examples, then fine tuning perhaps, or improving your chunking strategies, whatever it is in your system that you have access to, but let it be driven by your error analysis.
All right. So there's a paper here by Shreya Shankar and her colleagues. If you don't know who Shreya Shankar is, I highly recommend following her or getting to who she is. This is who I'm teaching a course on evals. This is who I'm teaching it with, Shreya, just so you know. But if when you read this paper, there's a lot of good stuff in this paper, and I've highlighted it, but we won't go through all the highlights. You could actually go through all the highlights, and they would all be very interesting presentation. There's one, was looking through this because I'm doing a presentation on this topic of, we don't have time to get into it, but I'm doing a presentation on something. And I'm just going to read this part to you. The subheading is alignment is iterative, criteria, and implementation specific. So participants needed to externalize criteria in order to grade outputs, but they also needed to grade outputs, providing feedback on why bad outputs were bad in order to externalize their criteria. This is systematic analysis done across many engineers working on AI. So it's not just like me have an anecdote or whatever. This is like a large scale study of AI engineering. I think it's pretty clear. So what's hard is not, I don't know, this all kind of takes work, but you need to look at the data and go through this error analysis process. If in your mind, if evals is just a metric, then you're thinking about evals wrong. It's not a metric. It's an entire process.
We have a related question from Yas, who's in Melbourne, Australia. She has a wonderful question about how do you balance quantitative and qualitative heuristics while evaluating? Because in normal ML evaluations, a lot of the time it's fairly quantitative. So do you have any recommendations about qualitative versus quantitative heuristics when designing evaluations based on the type of evaluation, for example, RAG?
Yeah, that's the deep topic. Qualitative evaluations are more suited for LLM as a judge. Quantitative is more sometimes code-based. RAG specifically is unique in nature because there's like a very standardized way of evaluating RAG. You can use information retrieval metrics, and we've narrowed down to especially because RAG, a lot of it has to do with retrieval. So the R in RAG. And so there's systematic ways of like standard approaches to evaluating retrieval. Yeah, that's my high level. It's a deep topic. Like
Absolutely. And I can link actually to some of Jason Liu has some nice resources on this as well that I'll link to. Hamel, I appreciate we're past time and I know how busy your schedule is. Thank you so much for joining us. And Hamel may not have time to respond much in Discord, but we've got other ways to connect with him, including joining his course if you like, which I'm going to give a brief plug for now. But you please do leave if you need to right now, Hamel. And we appreciate your time.
Thank you for having me. Appreciate it.
Such a pleasure, man. And appreciate your time and expertise and friendship as always, dude.
Yeah, likewise. Thank you.
Awesome. Thanks for listening, everyone. And thanks for sticking around to the end of the episode. If you're enjoying the show, please leave a review and a 5-star rating on whatever app you're listening on. It really helps. I'd also love to hear what topics you'd like us to cover and any guests you'd like to hear from. Feel free to reach out on LinkedIn or on Twitter. The podcast handle is Vanishing Data, and I'm Hugo Bound. See you in the next episode.